We will solidify our understanding of bond math by calculating the net present value of a series of cash flows. We will do this in two ways, one manually and two making use of the Excel NPV function. This way we will satisfy ourselves that the two calculations exactly match. We start with the information visible on screen now. In row 7 we have the principal, which is $10,000. And then down below, starting row 9, we have the bond schedule. This is a schedule of all of the cash flows coming from the bond. We have the coupon, which is in cell A11, that's 3.8%. And then we have the various periods. Those are denoted by the letter I, and they number from 1 through 5. So these values tell us how many years from now we are going to get these cash flows. If you're wondering why the value 5 appears twice in row 15 and row 16, that's because at the end of the 5th year, we are also going to get back our principal, that's $10,000. In column C, we see the future values of each of these cash flows. So column C contains the dollar amounts that we are going to receive at the end of the years contained in column B. Each of the years 1 through 5 will see us receive the coupon payment. The coupon payment is 3.8% of the principal, so that's $380. At the end of the 5th year, we also get back the principal of $10,000. Now, the easiest way to convert a future value into a present value is by applying the inverse of the compound interest formula. And that compound interest formula requires the calculation of 1 plus y. Y here is the rate, that's 3.8, and 1 is simply the principal factor. So we go ahead and calculate that for all of the cells in column E. We can think of the rates in column E as the annual rates which apply between successive years. Then in column F, we convert the annual rate into a cumulative rate. Here, because all of our rates are equal to each other, we can simply raise the annual rate to the number of years that have elapsed. So that's 1 plus y the whole raised to I. We can copy this formula down, and we've now got the cumulative rates for each year from 1 through 5. We can see that these rates successively increase, and this is a way of expressing the power of compounding. Now we can go ahead and compute the present value of each future value by simply dividing the future value by the corresponding discount factor. For instance,